When dealing with electrical installations such as pool heaters, understanding the function and application of disconnect switches is crucial. A disconnect switch serves to isolate a circuit, allowing for safe maintenance or repairs. These switches come in two primary types, fused and non-fused. A fused disconnect provides overcurrent protection in the event of a fault. This means it incorporates fuses that will blow, interrupting the circuit if the current exceeds a safe level. By doing so, it prevents damage to the equipment and the electrical system. A non-fused disconnect, on the other hand, does not provide overcurrent protection. Its main purpose is to disconnect the circuit for maintenance or repairs. It is essentially just a switch that opens and closes the circuit without any built-in protection against excessive current flow. When selecting a disconnect for a pool heater circuit, it is generally recommended to use a fused disconnect. This is because it offers better protection against electrical hazards. In the event of a short circuit or overload, the fuses will blow, preventing potential damage or fire. Now let's discuss ground fault circuit interrupters, also known as GFI breakers. The National Electrical Code, or NEC, does not mandate GFI protection for pool heaters. However, it is generally recommended to install a GFI breaker on the pool heater circuit as an additional safety measure. A GFI breaker works by monitoring the current flowing through the hot and neutral conductors of the circuit. If it detects a difference in current, it indicates that some current is leaking to ground, which could be a sign of a ground fault or shock hazard. In such a case, the GFI breaker will trip, quickly cutting off power to the circuit and preventing electrical shock. While the NEC might not require GFI protection for pool heaters, the potential benefits of enhanced shock protection often outweigh the costs of installation. Using a fused disconnect switch is recommended to protect the pool heater circuit against overcurrent. It is also advisable to consider installing a GFI breaker for enhanced shock protection, even if it's not mandated by the electrical code. This layered approach to safety can provide peace of mind and minimize the risk of electrical hazards. Electrical safety is of paramount importance, especially in environments such as around swimming pools. Understanding the role of various protective devices and following recommended practices can significantly reduce the risk of electrical accidents. Always consult with a qualified electrician for specific installation requirements and to ensure compliance with local electrical codes. A fused disconnect is designed to protect electrical circuits and equipment from overcurrent, which can result from short circuits or overloads. The fuses inside the disconnect are calibrated to blow, interrupting the circuit when the current exceeds a predetermined level. This prevents overheating, insulation damage, and potential fires. Non-fused disconnects, while not providing overcurrent protection, still play a vital role in electrical safety. They allow for safe isolation of circuits for maintenance and repairs, ensuring that no electricity is flowing through the circuit while work is being performed. The selection of a fused disconnect should take into account the specific electrical requirements of the pool heater, including its voltage, current rating, and any applicable codes or standards. The fuses should be sized appropriately to provide adequate protection without causing nuisance tripping. GFI breakers are highly sensitive devices that can detect even small amounts of current leakage to ground. This sensitivity is crucial for preventing electrical shock, as even a small current can be lethal under certain conditions. GFI breakers are designed to trip quickly, typically within milliseconds, to minimize the duration of any potential shock. Regular testing of GFI breakers is recommended to ensure that they are functioning properly. This can be done by pressing the test button on the breaker, which should cause it to trip. If the breaker does not trip when the test button is pressed, it should be replaced immediately. When installing a GFI breaker, it is important to follow the manufacturer's instructions carefully. Incorrect installation can compromise its effectiveness and may even create additional safety hazards. The NEC provides specific guidelines for the installation of GFI protection in various locations, including around swimming pools. These guidelines are intended to minimize the risk of electrical shock and should be followed closely. It is important to note that GFI breakers are not a substitute for proper grounding. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device, fuse, or circuit breaker to trip and clear the fault. GFI breakers, on the other hand, detect current leakage to ground and trip independently of the grounding system. Fuse disconnects and GFI breakers are both important components of a comprehensive electrical safety system. They work together to protect against different types of electrical hazards, providing a layered approach to safety. In addition to fuse disconnects and GFI breakers, other safety measures should be considered for pool heater installations, such as proper bonding and grounding of all metal parts, and the use of non-conductive materials where possible. Bonding involves connecting all metal parts of the pool and its surrounding structures together to create a common electrical potential. This helps to prevent voltage differences that could cause electrical shock. Grounding provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. Non-conductive materials, such as plastic piping and enclosures, can help to reduce the risk of electrical shock by preventing current from flowing through these parts. Regular inspections of the electrical system are also important to identify any potential hazards and ensure that all components are functioning properly. These inspections should be performed by a qualified electrician who is familiar with the specific requirements for pool electrical systems. Proper maintenance of the pool heater itself is also essential for safety. This includes keeping the heater clean and free of debris and ensuring that all electrical connections are tight and secure. Pool heaters should be installed in accordance with the manufacturer's instructions and all applicable codes and standards. This includes proper ventilation, clearance from combustible materials, and protection from the elements. It is important to use only qualified electricians for all electrical work related to pool heaters. These professionals have the knowledge, skills, and experience to ensure that the installation is safe and compliant with all applicable regulations. Electrical work should never be attempted by unqualified individuals, as this can create serious safety hazards. In addition to the specific requirements for pool heaters, there are also general electrical safety practices that should be followed at all times. These include never working on electrical equipment while it is energized, always using properly insulated tools, and never overloading circuits. Electrical safety is a shared responsibility, and everyone should be aware of the potential hazards and take steps to prevent accidents. By following these guidelines, you can help to create a safe and enjoyable pool environment. Firstly, fuse disconnects are essential safety components that provide overcurrent protection, preventing damage to equipment and electrical systems. Secondly, non-fuse disconnects are primarily used to disconnect circuits for maintenance or repairs, without offering overcurrent protection. Thirdly, it's recommended to use a fuse disconnect for pool heater circuits for enhanced protection against electrical hazards. Fourthly, the National Electrical Code does not mandate GFI protection for pool heaters. It's a recommended practice for added safety against electrical shock. Fifthly, GFI breakers detect differences in current between hot and neutral conductors, indicating potential ground faults and shock hazards. Sixthly, installing a GFI breaker offers an additional layer of protection, tripping the circuit when a ground fault is detected. Seventhly, using a fuse disconnect protects the pool heater circuit against overcurrents. Eighthly, considering installing a GFI breaker is wise for enhanced shock protection, even if not required by code. Ninthly, the combination of fuse disconnects and GFI breakers provides a comprehensive safety approach for pool heater installations. Tenthly, regular inspections and maintenance by qualified electricians are crucial to ensure the ongoing safety and proper functioning of electrical systems. Overcurrent protection is a critical aspect of electrical safety, preventing damage to equipment and reducing the risk of fire. A fuse is a simple yet effective overcurrent protection device. It contains a thin wire or strip of metal that melts and breaks the circuit when the current exceeds a predetermined level. Fuses are available in a variety of sizes and ratings to match the specific requirements of different circuits. Circuit breakers are another type of overcurrent protection device. They are similar to fuses in that they interrupt the circuit when the current exceeds a safe level, but they can be reset and reused. Circuit breakers use a bimetallic strip or an electromagnet to trip the breaker when an overcurrent is detected. There are different types of circuit breakers, including thermal, magnetic, and electronic circuit breakers. Thermal circuit breakers use a bimetallic strip that bends when heated by an overcurrent, causing the breaker to trip. Magnetic circuit breakers use an electromagnet that trips the breaker when the current exceeds a certain level. Electronic circuit breakers use electronic circuitry to detect overcurrents and trip the breaker. Grounding is another essential safety measure that provides a path for fault current to flow back to the source, allowing the overcurrent protection device to trip and clear the fault. Grounding systems typically consist of a grounding electrode, such as a ground rod or a metal water pipe that is connected to the electrical system. The grounding electrode provides a low-resistance path for fault current to flow back to the source. Bonding is the practice of connecting all metal parts of an electrical system together to create a common electrical potential. This helps to prevent voltage differences that could cause electrical shock. Bonding is typically accomplished by using bonding jumpers to connect metal enclosures, conduits, and other metal parts. Electrical shock occurs when a person comes into contact with an energized conductor and a path to ground. The severity of the shock depends on several factors, including the voltage, current, and duration of the contact. Electrical shock can cause a variety of injuries, including burns, muscle contractions, cardiac arrest, and death. Preventing electrical shock is a primary goal of electrical safety. This can be achieved by following safe work practices, using properly insulated tools, and installing ground fault circuit interrupters. Lockout/tag-up procedures are used to prevent accidental energization of electrical equipment during maintenance or repairs. These procedures involve disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned on. Arc flash is a dangerous electrical hazard that can occur when a short circuit or other fault creates a high-energy electrical arc. Arc flash can cause severe burns, blindness, and other serious injuries. Preventing arc flash requires the use of appropriate personal protective equipment, such as arc-rated clothing and face shields. Electrical safety training is essential for all workers who may be exposed to electrical hazards. This training should cover topics such as safe work practices, hazard recognition, and the use of personal protective equipment. Regular refresher training is also important to ensure that workers stay up to date on the latest safety procedures. The Occupational Safety and Health Administration, or OSHA, is a federal agency that sets and enforces workplace safety standards. OSHA has specific regulations related to electrical safety, and employers are required to comply with these regulations. The National Fire Protection Association, or NFPA, is a non-profit organization that develops codes and standards related to fire and electrical safety. NFPA 70, the National Electrical Code, is the most widely used electrical code in the United States. It is essential to consult with qualified electrical professionals and adhere to all applicable codes and standards when working with electrical systems, especially in potentially hazardous environments like pool areas. These experts can assess the specific requirements of the installation and recommend the most appropriate safety measures. This proactive approach ensures a safe and reliable electrical system that protects individuals and equipment from potential harm.